Not every project will go underground, but there are more projects that could go underground if we, as an industry, do a better evaluation. They're going to come up with new devices to build it better, faster, cheaper.
This is EnergyCast, and I'm Jay Downhauer. Today we're talking about burying more high-voltage transmission lines, why utilities are taking a fresh look at a decision that is usually considered prohibitively expensive. During my time in transmission, we upgraded several overhead transmission lines, but never buried them. But at times, when there was a projected budget surplus in that department, I remember recommending that burying lines would make a lot of sense. It's aesthetically pleasing, requires about the same engineering and construction as overhead, and as my guest puts it, improves resiliency. That's a concept that's probably giving undergrounding that second look. From wildfires in California to hurricanes in the Gulf, natural disasters can wreak havoc on our grid. And as my guest says, these high-impact, low-frequency events are becoming more frequent. The standard rule of thumb I was always told when it comes to building an underground line is that it would cost between 3 and 5 times as much as if you hung them from a tower. But my guest says that new efficiencies, techniques, and materials are bringing down the costs. Plus, he says, over the life of these assets, namely pure expense activities like tree cutting, are making the total cost of ownership closer to even. Will undergrounding ever be as affordable as overhead? Unclear. But in some cases, it may be undeniable that burial has its benefits. My guest today is Mike Beeler, National Spokesman for the Power Delivery Intelligence Initiative, or PDI2. Mike has spent his career in the transmission sector, including many projects in both the overhead and underground space. As you might guess, PDI2 is an advocacy group promoting more underground high-voltage transmission lines. I've been a big fan of this type of work for several years, but money talks, so I never saw burial projects in action. I was curious if there were more arguments for underground, and if we're possibly on the cusp of an undergrounding surge. California's utility, PG&E, recently announced billions in new funding for this type of work, so I was curious if other utilities would follow. I hope you enjoy my conversation with Mike Beeler. We're here with Mike Beeler, National Spokesman for the Power Delivery Intelligence Initiative, or PDI2. And Mike, there are already some major organizations representing the T&D and power industry. What is PDI2 trying to address?
Well, Jay, thanks for the question. I appreciate being with you today. PDI2 is a group of contractors and consultants, cable manufacturers, and businesses that are engaged in underground electric transmission and distribution, T&D. Really, they are there to advocate that planners and engineers give a good, close evaluation of underground versus overhead. For so many years in the industry, there's been these rules of thumb that, underground's just more expensive, it doesn't make sense. Well, we just fundamentally disagree with that. We think that the 21st century cost of underground is coming down. We think that there's a lot of unquantifiable but otherwise tangible benefits of underground versus overhead. We don't even really talk about aesthetics, but I believe personally that aesthetics is a big deal as well. So these contractors and consultants and manufacturers that make up the membership of PDI2 basically want just a fair shot. They want a good evaluation. Not every project will go underground, but there are more projects that could go underground if we, as an industry, do a better evaluation.
Do you think there was a conflict between, there's a lot of companies that do a lot of infrastructure that goes above ground, the structural steel that everyone sees. Was there maybe some conflicts there?
Well, I think there's a good balance of overhead versus underground. If you look around the country in the newer cities in America, let's say just North America, many of the lines that they put in are underground. I'll say this at the distribution level. I won't say that at the transmission level yet. There are plenty of consultants and contractors in the country that do both overhead and underground. probably more overhead than underground today, but there are also then a lot of vendors or manufacturers that are in the underground business, and they know it's coming. Internationally, around the world, utilities are building more underground in developed Western countries than they're doing overhead. Yes, if I'm building concrete poles or steel lattice towers or things like that, or I have a tree trimming business, is this going to impact me? Yeah, it could be, but we're not going to convert the overhead transmission and distribution system in this country overnight. It's going to take decades of work, starting today, really, Jay, to convert the overhead system to underground in the places that it makes sense.
Yeah. And my transmission lines, the high voltage stuff to underground, this is expensive, but I've always understood it to be much more expensive than the overhead variety. What's the main reason the utility would want to incur that kind of expense and bury high voltage lines?
You'd want to bury that if you don't get a permit to put it in overhead. I mean, if you're going to put a 138 kV line in my backyard, I'm probably going to tell you a dozen reasons why I don't want it in my backyard. And there's people that have done that for a long, long time. In my experience at Hawaiian Electric Company, it was back in the early 90s. I mean, the neighborhoods basically said, we don't want to see this overhead transmission line. So we were starting to look at underground even back then. And I remember a project manager one time said, you engineers, you will build what we can permit. And she was absolutely right. If you can't get the permit to build the line overhead, then underground is a great alternative. If you've got to build that line, and you have a lot of good fundamental system planning reasons why, we need to build this high voltage transmission line.
Yeah, a lot of what I'm thinking of is those big right-of-ways, the trees cleared on either side. I had a guest come on to discuss California. We know that PG&E has announced plans to bury many of their lines, but wouldn't it be cheaper to simply clear those right-of-ways? Every utility in the country does that. I think California, with all their wildfires, has come under some scrutiny about maybe some of those right-of-ways not being clear. Can you kind of help us understand?
Sure. California is a really interesting situation, very challenging, especially with the big investor owns in California. And as you mentioned, Pacific Gas and Electric has announced this last summer that they're going to spend $15 to $30 billion to underground just 10% of their T&D system. So that's a big initiative. But to your question, couldn't they just clear the right-of-ways? California Public Utilities Commission, which is their regulator, has very, very strict rules as to what they need to do and what kind of clearance there needs to be between a tree limb and a distribution or transmission line. And PG&E has worked diligently with their vegetation management programs to do that. The problem is that anything that's outside the right-of-way sometimes can fall into the right-of-way and cause a problem. They're called danger trees. They're trees that might be dead or dying on the outside of the right-of-way that the utility does not have the responsibility or right, theoretically, to go and impact. And those trees could fall into the right-of-way. And on top of that, another huge issue in California is forestry management and how is the forest floor managed. Some people advocate to let it go and let all the debris build up, and then every once in a while fire comes through and burns it out. Other people say, no, you need to maintain that forest floor and keep that deadfall and that debris off the floor because that's what causes these massive fires. So there's an environmental debate about that in California, and the utilities are caught in the middle, and it's very challenging for them. So yeah, you could say, okay, we're going to clear cut 100-foot right-of-way for this transmission line in Northern California, but there are still other issues that come up that at the end of the day, you've got an electrical mechanical system that sparks, and you are going to have, things that happen and has happened in the last several years with the wildfires throughout all of California, frankly, Jay, throughout the West.
Yeah. So rather than make a regulatory exception for danger trees, we're just going to spend tens of billions of dollars?
I think what the new CEO, Patty Poppe, has determined at Pacific Gas and Electric is that for decades, this is the way we ran the system. And these latest wildfires a couple of years ago, they killed 30 people, they burned down a couple of communities, and it forced the company essentially into bankruptcy. Why would we come back and rebuild and do the exact same thing over again? She said, we can't afford not to underground some of these lines. And therefore, they made the announcement that they're going to underground 10% of their transmission and distribution system. And I believe, and PDI2 believes, that that's just a start. At some point in time, they're going to say, okay, we've got 10% done and we need to move on to the rest of the system, or the next 10% of the system, if you will.
Yeah. And by the way, at some point, I hope to talk to PG&E. That criticism isn't against them. It's against the regulatory group, if anything. But I certainly understand that, look, I mean, even if you did clear the right-of-ways, that could still lead to the same result. So maybe undergrounding works best in those situations.
Yeah. So here's another factor as well, is that money goes into the rate base, certainly. And so there's some concern that you're raising the cost of electricity because you're paying a higher capital cost on the front end. But over the life of the asset, we at PDI2 maintain that the total cost of ownership of underground versus overhead is less over the life of the asset. And this is reported by utilities to the Federal Energy Regulatory Commission, that the cost of their O&M, operations and maintenance, on their transmission and distribution underground is less than the cost of the O&M on their overhead. So over the life of the asset, the cost of owning that underground transmission or distribution line is actually less. So if you take the whole life cycle cost analysis, it looks pretty good. And that's at PDI2, that's really what we want engineers and planners to start to do. It's like, look at it over the life of the asset. Maybe on the front end, the cost of underground is more, but over the life of the asset, it's less, or at best at parity. And oh, by the way, there's things that you can't quantify, like human safety, customer safety, aesthetics, things like that you can't really quantify, but are additional benefits of underground.
Yeah. The estimates for undergrounding compared to overhead is, I've heard, as much as 3x.
Yeah, so what we're trying to say is no more rules of thumb. Each individual project, just like if you estimate the cost of an overhead line, these days, you cannot just say, okay, well, an overhead line is going to cost me $100,000 a mile, and an underground line, same distance, same route, which wouldn't make any sense. You wouldn't route it in the same way you'd route an overhead line anyway, is going to be 3x or 5x. So no more rules of thumb. Every project needs an evaluation of not only the capital cost, but then that total cost of ownership. Is that harder to do for planners and engineers? Okay, maybe, but is it the right thing to do? Absolutely, it's the right thing to do. It's the prudent thing to do. It's the thing that utilities need to step up and start to do, and some actually are. And you watch what happens at PG&E. PG&E is going to lead the industry on new ways of designing and building transmission and distribution underground. They're going to have new economies of scale of things that they employ in the process of constructing, in particular, underground in rural environments and in urban environments. It's going to be fun to watch. And then other utilities are catching on as well. There's a lot of work on strategic undergrounding out on the East Coast and in the southeastern United States. And these utilities are starting to share their success stories, the challenges they've had, their best practices, their lessons learned, and it's spreading throughout the industry, such that now members of PDI2 are coming back and saying, hey, our sales team was out in the C-suite talking to executives, and the executives at utilities across America and North America are talking about underground. Oh, what do you know about underground today? Are you hearing more about underground? Cost of underground's coming down. It makes more sense to do underground. And that's what's happening in the C-suites now. And PDI2 is proud to be a resource for, not only executives, but their planners and engineers as they start to ask these questions.
So, Mike, I'm a Louisiana guy, and the other example you and I discussed when we first was talking was the transmission lines leading into New Orleans. They were wiped out during Hurricane Ida in 2021, just like Hurricane Katrina 16 years earlier. This is very similar to the California example, I think. So I know many of these big lines are on those platforms that span the water. You can see them as you're driving in. What's the discussion down there?
Well, I don't know what the discussion down there internal to the company at Entergy is. I know what my thoughts are in it is that you lost all your transmission feeds to New Orleans in 2005 with Katrina. You went back and essentially built the same overhead system. And then 16 years later, you're right back and they lost all 8 major transmission lines feeding the city of New Orleans. And the city was out of service, out of a fundamental critical electric service for up to 3 weeks in some places. I just find that completely unacceptable. And so the CEO comes out and says, we're doing our best and God bless our linemen. They're out there risking life and limb, and they are. And they're doing a great job rebuilding the overhead system exactly the way it came down. And to me, that just makes no sense. And I've been in this industry now for over 40 years, and I'm an overhead transmission line design engineer. I'm an underground transmission line design engineer by education and early experience. And I know what it takes to do both. And I just don't fundamentally understand why Entergy can go back and look at everybody with a straight face and say, well, we're going to rebuild this overhead system again. And we don't know when the next big hurricane or flood's coming, but we're here to serve you. So I don't buy that. I don't think that's an acceptable answer anymore. And I think the industry is starting to say, we got to do something different. like they said at PG&E, we can't go back and do it the same way because we've got this increasing incidence of wildfires that are coming through and impacting our service territory. Well, at Entergy, it's the same story. Now, look, they have hurricanes down in South Florida, and Florida Power and Light doesn't lose Miami for 3 weeks at a time. So I'd say, what are the regulators doing in Louisiana? Why do the regulators allow them to go reserve a major city in the United States of America with overhead transmission when we know that it comes down in these high-impact, low-frequency events? Problem is, the low-frequency part of that equation, they're becoming seemingly more and more frequent and more impactful to the critical infrastructure, not just the electric infrastructure, Jay, but all the parts of our community that rely on electricity to run. The water purification, the water pumps for stormwater, especially in New Orleans, which is below sea level, the wastewater treatment, the telecom for police and fire and first responders. All of these things rely on electricity, and the electricity is out for 3 weeks. In my book, that's just unacceptable.
Yeah, I'm going to get real inside baseball for people who are familiar with that region. But leading into New Orleans, there's wetlands. There's, I guess, what you could consider swamp. There's a lake. You would underground the lines underwater, right? Would that be the idea?
Sure. I mean, what do you think is going to happen when we build offshore wind out on the East Coast? They're going to have an undersea cable that is going to carry the electricity from the collector stations to landfall. They are talking about the Champlain Express, which up in Lake Champlain, New York, they're going to put an freshwater lake cable. There's a big underwater cable up in Northern California that serves the greater San Francisco area. So undersea cables, underwater cables are not new to the industry. That's certainly something that we can do, not only here in the United States, but they've got even more experience in that internationally across the world. So the technology exists today. Might it be expensive? Yeah, it might be expensive to do that. Is it more expensive than losing a city for 3 weeks? See, one of the things, we don't even calculate the gross domestic product of the city of New Orleans that is lost in the 3 weeks with no electricity. These are the kinds of things that we need to start to talk about in the industry and say, wait, that has a value. Okay, it is more expensive to maybe put this cable undersea or underwater leading into New Orleans, but what's the cost of losing the city for 3 weeks? And I'll also say that directional drilling has come a long way too. Some of the members of PDI2 are big directional drillers. Well, some of these guys can do a 5,000, 6,000 foot directional drill. They bore a big hole 100 feet deep. They go under the lake and they bring the cable out the other end. If you're talking about distances of a mile or less, it is completely achievable and technically something that is on the table for planners and engineers.
It's funny that you mentioned offshore wind. I did an episode with Dominion Energy on their offshore wind project, and we went deep into the plans for transmission leading back to shore. All right, you mentioned the directional drilling. What do you do when you bury a transmission line? I assume you encase it in a concrete duct. Is the duct basically at the surface? Take us through how it's done.
Okay, so today, most high voltage transmission lines is going to be solid dielectric cable. So it's going to be a cable. We used to do high pressured fluid filled. We don't need to do that anymore. Technologies of cable design have advanced. So it's essentially, you're going to put in a duct bank, a duct system, maybe a 5-6 inch diameter duct, and you're going to pull that cable through that duct. And you're going to pull 3 cables for a 3-phase system. And that duct bank will be likely encased in something called fluidized thermal backfill, which is a low resistivity, thermal resistivity backfill that's harder than soil, maybe 1,000 PSI in strength as opposed to like a 3,000 PSI concrete. So you could chip it with a backhoe if you wanted to, but it's low thermal resistivity that allows the heat that builds up when these cables are operated at high capacity. These cables have to be able to expel that heat out of the backfill through the soil and let the heat escape. If you overheat the cable for too long, you degrade the life of the cable.
What about minimum approach distances when those high voltage cables are on the ground? Can you walk over? I don't know how minimum approach distance works when you basically have fill in between you and the line.
You could walk right over the top of it. It's not going to be an issue. The soil is going to protect you, and it's not like there's going to be some kind of inductive energy coming through the soil that's going to electrocute you. Not an issue at all. Some people would talk about electromagnetic fields when you're trying to route and permit a transmission line. Even with electromagnetic fields, it's a function of voltage and distance. The relatively low milligal level of an underground line relative to some of the things you might find at your distribution transformer or your electric blanket or a blow dryer is very, very low and not really a factor for most people.
In an earlier conversation, you said you didn't think voltages larger than that 100, 130 335, essentially the largest of the transmission lines. You didn't think those would be good candidates to be buried. But why is that? Why more of those mid-high voltages?
I think we start looking at 345 kV and 500 kV. I think you can make a case for going overhead. But I will say, again, if you cannot permit it overhead, then underground's a natural alternative. So there are some big transportation corridors right now, some railroad right-of-way corridors that some developers are trying to develop to bring wind energy resources to load centers in the east. And they're going to use railroad rights-of-way. So the Sue Green project, which is a fascinating project. I think it's a 400 kV direct current DC underground transmission line that runs in railroad right-of-way. That's because they're going to be able to permit that project. Up in New England, they built 345 kV underground back in the mid to late 2000s because they couldn't get the overhead permitted. They had to agree to build 24 miles of 345 kV underground. At that time, that was the longest stretch of 345 kV underground in the world because the public wouldn't otherwise permit the line. Out in Southern California, they built 4 miles of 500 kV solid dielectric underground because basically the public said, you will not build this overhead transmission line into the city of essentially of Los Angeles. And they forced them to go underground. And the regulators said, yeah, and they made the community and the ratepayers pay for it. So if you can't get big transmission lines permitted overhead, then it's just a natural thing to go look at it underground. And the technology today does exist for underground transmission in lengths of projects like I just described.
Say you do a conversion to underground, and I'm thinking of these right-of-ways in rural areas. Does the right-of-way go away? I mean, you wouldn't have trees growing over it, right?
Yeah, you'd want to maintain a right-of-way so that you could travel a right-of-way. So at a minimum, you'd want the ability to get a line truck through there that could service that underground transmission line and have access to your right-of-way. Remember, that right-of-way is one of the biggest assets that utilities have. The property and the rights-of-way that utilities own are a huge asset. So they're going to want to maintain that, be good stewards of it. They might put a running trail in there, a park system. There's all sorts of things, especially in suburban areas, that they could do. But, they're going to maintain that right-of-way to some extent, just not as aggressive. And are they going to let trees grow right over the top of the line? No. But could they be on the edges of where that 6-foot wide duck bank is, where a 12-foot road for men and equipment to get in? And then they're going to have manholes, on a straight run every 5,000 feet. So they're going to have the need to be able to set up equipment to get into the manhole and perform maintenance and things like that.
Going back to PG&E for a second, you said they were going to convert maybe about 10% of their lines. That's still quite a lot of mileage that stays status quo. What would be, and this should go for any utility's decision to bury lines, what would be a good test to determine, yes, this line makes good sense to bury?
Jay, that's a great question. And I think that's a fundamental question that engineers and planners are going to be challenged with at PG&E because, okay, you've got a limited amount of money, you've got a limited amount of time. The CEO has told everybody we're going to put 10% under the ground. Where do we start? So they're going to say, okay, well, we're going to start in areas that we have radial feeds to, that we can't build a microgrid, a diesel generator at, that has a high density of customers, that has the current radial feed is old and in poor condition. I mean, they're going to look at a lot of things like that. They're going to look at what's my total time of line restoration when that line does go down or when I do need to perform maintenance on it. How easy is it to get to? How challenging is it for me to get vehicles back into that area to do regular maintenance or even to do line repairs after a storm or a fire? I would hope at PG&E that they've already had that discussion and they know where they're going to go. They need to hire contractors and they need to put a shovel in the ground right now, metaphorically speaking. They need to start right now because, Patty Poppy made that commitment last summer of 2021. And by summer of 2022, she needs to be able to point to some projects where they've got some success and they have successfully undergrounded some of that system. And certainly we know fire season starts about June 1st out in California, and they do not want to have a fire in a place where they haven't, at least at a minimum, been able to say, we've started to remedy this dangerous situation that we've got with regard to our T&D system and the fire danger in Northern California.
Mike, earlier regarding the expense question, labor gets more expensive every year, but are there technologies or materials making this more affordable than it was, say, 10, 15 years ago?
Okay, that's a great question. I think that design resources are more advanced and geographic information systems and some of the design tools help. I think that contractors are developing new tools and techniques and economies of scale, the ability with an economy of scale to do some things at a very large level. You watch what some of these equipment manufacturers do when they realize that the amount of underground that's going to go in North America is going to grow exponentially. They're going to come up with new devices to build it better, faster, cheaper. So that's exciting. Cable designs and terminations and splices have advanced. The cable can last, if it's well taken care of, and you go in on the front end and benchmark the condition of that cable as a part of the contract. If the owner operates that cable within design parameters, it should last 100 years. Okay, that's fantastic. That is a long time. The splices and terminations are factory made today. A lot of the things that had to be done in the field in years past are done in the factory now. So you've got all that quality control on top of that. And as utilities move from a more overhead centric philosophy and way of doing business to a more underground centric philosophy and way of doing business, you watch as some of the things that they just do in using some of the Six Sigma lean principles in how they make the processes of designing and building underground and then operating and maintaining underground versus their old overhead mentality. We're going to see all sorts of advancements in the coming years. We're going to see companies like Dominion and Duke and We Energies and Pacific Gas and Electric. They're going to be leading the industry on these things. And then they share that in the industry, and other utilities go, oh, you know what? We can do that too. We should be doing that. Oh, my regulator is going to ask me to do that, and I better have a good answer for him. And the answer is not what Entergy comes back with and says, well, we're sorry, we're on it, and we're going to go back and get you back in service as quick as we can with the same overhead that came down 3 weeks ago. That's not the right answer anymore.
Look, I think burying transmission lines captures the imagination, but you also said there's a lot of work on the distribution side, the lower voltages that feed our homes and neighborhoods. And this seems to be a lot more common, especially in big cities. Even my neighborhood back in Bossier City, Louisiana, had underground distribution lines. So what's going on there?
Well, we've seen at Dominion, they went to their regulator and they said, hey, we want to do some strategic undergrounding to improve reliability. And the regulator said about 7 or 8 years ago, your reliability is pretty good. We don't need you to improve reliability. And they said, well, actually, what we want to do is we want to improve resiliency. Resiliency is a word you hear a lot about now in the industry. And resiliency is the ability to recover from a high impact, low frequency event with little or no outage of customers. And the regulator said, okay, that makes more sense. Dominion said, we want to reduce the total time of line restoration, the total amount of time it takes us to go in and repair these lines. We want to reduce it from like 5 or 6 or 7 days after a major ice storm or a major hurricane to maybe like 3 or 4 days. That's like 2 or 3 days fewer that the governor of Virginia is calling the CEO of Dominion and saying, when are you going to get my customers and my constituents back in service? They started doing that about 8 years ago. They've got some great lessons learned and some best practices at Dominion. They're starting to share that with other utilities. Duke's got a program. Tampa Electric had a program. Georgia Power's in a multi-billion-dollar initiative to do overhead to underground conversions. Florida Power and Light's got their Storm Secure pilot. That's a $100 million a year pilot. That's a big pilot. They're getting some good results from that. We Energies is doing some great work with underground. You see some of the California utilities even starting to look at it. So I think from the coasts and from We Energies up in Wisconsin, I think those lessons learned are going to start to apply. Utilities are looking for ways to invest in the grid to make it more resilient. Everybody's talking about storm hardening. We're going to harden the system for a higher incidence of big impactful storms that are coming, and they're looking for that, and regulators are receptive to it. So with storm hardening comes not only bigger poles and bigger conductor, but also strategic undergrounding as well. And it kind of goes hand in glove together. And utilities are getting a great reception from their regulators for the most part, certainly on the coasts. And I think regulators around the country and North America are taking notice as well.
Yeah, so moving these lines underground is far more than just an aesthetic move.
Well, I personally like aesthetics, but yeah, at the end of the day, it's about the total cost of ownership over the life of the asset. And I think that's the point that the Power Delivery Intelligence Initiative is trying to make to planners and engineers and executives of utilities is, hey, it makes a lot of sense when you look at the total cost of ownership over the life of the asset. Now, what makes more sense? I mean, you have to go back and trim that tree to maintain your regulators' very restrictive vegetation to line clearances, and you have to trim that tree every year and chop half of it out. I've got a picture of a tree in Hawaii. The tree is literally V-shaped as a distribution line with a lot of telecom and cable TV underneath it, runs right through the middle of what otherwise might have been a beautiful tree-lined street. How long do you just keep doing that and not really add it all up? And so that's what we're challenging engineers and planners to do. And at PDI Squared, we're giving them the resources as best we can as a group of contractors and consultants and vendors that are advocating for that as best we can. We're giving them the resources to help make good decisions in that regard.
All right. Very cool. Mike, I'm going to finish with a lightning round of your thoughts on different energy technologies, starting with natural gas.
We have a 100 to 200 year supply of natural gas in this country. We are going to use it. And if I am a gas utility or an electric gas utility, I'm looking for ways to capitalize on my distribution gas system. And one of those things that these utilities are looking at now is introducing renewable natural gas and hydrogen.
Crude oil.
It's another resource that we have in this country. In the previous administration, we were literally energy independent for the first time in my adult life. And it was an exciting time. Gasoline was cheap, life was good, and we weren't paying foreign entities for the crude oil. Again, 100-year supply at least of crude oil. And when we thought we were running out of oil, guess what? We advanced technologies of horizontal directional drilling and fracking. And guess what? We could get to additional oil resources. They are there and they're waiting to be developed.
Nuclear.
Love nuclear, would love to see small modular reactors that is built in the factory and delivered on a skid. In the meantime, Southern Company is trying to build Vogtle Units 3 and 4. Big, expensive, challenging project. And we're going to be really glad 10 years, 20 years from now that we've got a nice, good, clean resource of baseload fuel called the Vogtle plant, Units 1 through 4.
Coal, and I'll add coal with carbon capture.
100 to 200 year supply of coal in this country. We're still mining it, and we're shipping it to other parts of the world. We can make coal as clean as you want to pay for. I'm not bullish on carbon capture. Unfortunately, I think that's a lawsuit waiting to happen someday when carbon then escapes from this cavern that I've sequestered it in for the last 20 years. We can do better with coal without carbon capture. We could find ways to use it if we put our minds to it.
Wind.
A great resource, but at some point in time, you're going to have some storage to back up the wind. I want to take the production tax credits off of it, the investment tax credits off of it at some point in time. Let it stand on its own against other resources out there and let the chips fall where they may.
Solar.
I think solar technology is advancing rapidly. There's probably things being done with solar films that we haven't even dreamed about. They're building solar because the regulators want them to build solar. Even when it doesn't make necessarily good economic sense, they're still doing it. It's a great investment for the utility because 20 years from now, they're going to own the land that these solar farms are built on. But at the end of the day, when the sun is not shining, you got to have storage to back it up.
Biofuels.
I'm not very bullish on biofuels. I think if you've got a lot of wood chips I need to burn, that's fine, but that's not going to light the buildings and air condition and space heating that we need.
Hydroelectric.
I love hydroelectric, and it's a great way to have pump storage and do wonderful things with water resources, but we're not going to build any big dams ever again.
Geothermal.
Love it. I worked at Hawaiian Electric Company. You'd think they could run the entire island chain on geothermal, but they don't do it for some reason.
Energy storage.
I like hydrogen, less bullish on lithium-ion batteries because of where the critical earth elements are found. Storage will be a necessary component for intermittent resources like wind and solar.
Electric vehicles.
I think electric vehicles are very cool. I wish I could afford to drive one. And I think that we will build the charging infrastructure when it's needed. I see a lot of electric vehicle charging stations in places that are just never used. This new infrastructure program's got money for electric vehicles. I think that's just tax dollars being wasted. If a utility wanted to build electric charging infrastructure, they would do it, and their regulators would approve it because it made good business sense for them to do.
Energy efficiency.
You know, the low-hanging fruit has been picked on energy efficiency. And today, with LEED certified buildings, they're designing energy efficiency as much as the owner wants to pay for it. But when electricity is 10 or 12 cents a kilowatt hour, it makes it hard to figure out what you're going to do next if you've already picked the low-hanging fruit.
And then finally, fusion power.
That's probably a long way out. If we can't do small modular reactors, we're not probably going to be able to take it to the next step. Time will tell.
All right, Mike Beeler, PDI2, thank you so much for your time.
Thanks, Jay. It was a pleasure to be with you today.
That was Mike Beeler, spokesman for PDI2, the Power Delivery Intelligence Initiative, an organization advocating for the burial of transmission lines. I want to thank Mike for his time, as well as Lee Mann at Clarion Events for making the introduction. As you know, I've done quite a bit of work with the Power Gen conferences, and Lee pointed me in Mike's direction when I told her I was having trouble finding an expert on this topic. I wasn't disappointed. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy and Twitter at Host Energy Cast. All guests are sent the wrong completed audio of the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 132. Be sure to join us next week when we learn how a company known for water recycling is making a big splash in the sustainability of wind power. Until then, I'm Jay Downhauer. We'll see you next time.